Hello! In this movie I will show you how to perform relaxometry with the Emalytics preclinical software. Therefore I will open the software first, and you can find an example dataset under Tutorials, MRI, Relaxometry T2, Load Example Dataset. What you can see here is a T2 weighted scan of a 96 well plate, and the wells are filled with different contrast agents with different T2 relaxation times. And the scan has 19 time points. You can go to the time menu here, and now you can go through this 19 time points. Like this. And what you can see is that some wells get darker quickly than the others because they have a higher R2 value. And the purpose of relaxometry is to quantify these R2 numbers, or R1 for T1 weighted images. So you can find the relaxometry menu here on the top. You can see that you can perform T1, T2 class-based or voxel-based analysis, or also T2 based. And first we will perform some T2 voxel-wise. And as I say, now the R2 values or R2 star map is loaded as overlay, and we can find it here. We can adjust the windowing a little bit, like this. So what happened? For every voxel, an exponential curve was fitted to the intensity over time curve of that voxel. You see that the voxel with a quick decay have a high R2 value here on the right side at the bottom. And where's the others? Here on the top. They have a lower R2 value. And this was now calculated per voxel, but we can also analyze it per region. So I will undo this. And first we have to define regions, and I will use the scribble drawing for this. So I will call it A. I press F3, F4, and then F1. And also here the next region, I will call it B. F3, F3, F4, F1, and the last one C, in a similar way. Okay. And now what you can do, you can select A, for example, as input class, and then you go to relaxometry, T2 class-based input class, and it will be saved as a CSV file. However, I already calculated it and will show you the results. So this is the T2 signal curve for region A, and there are two fits actually. One is just an exponential fit, and you can see the parameters here. And this is actually here the R2 value here, or the result. And there is a slightly different fit which involves an offset here called fit offset. But in this case the offset is 0 in this example, so the fit is very accurate to the curve. And this was for the first well, for A. I also calculated it for B here, and here the curve is a bit more steep, so the fitted value is a bit higher than before. Yes, and again also here the offset is 0. And now we come to well number C here. And this curve is a bit more extreme on this example because the curve is going down very quickly here. And the blue curve, the intensity, is the original intensity curve. And now we have the two fits here. And the two fits, they are different because we have this long tail here, this non-zero tail with a lot of non-zero values. And if you just perform a simple exponential fit, like this fit here in orange, it will not match the original intensity very well, so the blue curve. But the fit with the offset is a bit better here in gray, and you will get more accurate R2 values in this case. So you can avoid an underestimation of these extreme R2 values, which can happen if you use just a simple fit. For T1 relaxometry, I will show you the curve in the manual because we don't have an example dataset implemented in the software yet. So you can go to Help, Show Manual. Then I will go to relaxometry here. And this is here the T1 signal curve. And it actually comes from negative values and goes up to the positive. And it's also an exponential curve. And what we get in the image is just the absolute values. So because we have this absolute part in the formula here, and it's a kind of flipped up. So the curve has this function here, and that is a fit performed as a fit. And okay, that's all for T1 and T2. And I hope it helps. Thanks. Bye bye.